Science Snake. Hello, welcome to my YouTube channel Science Snake. Today we're looking at balancing equations, so let's go ahead and do the first problem. Before we get started, let's take a look at a couple vocabulary terms. The first one is a coefficient. It's the leading number in an expression, followed by a subscript, which is the bottom number after a variable, or in chemistry, after an element symbol. Third vocabulary term is reactant, a substance that takes part in and undergoes change during a reaction, whereas a product is formed at the end of a chemical reaction. During the chemical reaction, reactants are transformed into products after passing through a high-energy transition state. Let's take a look at how number 1 was balanced. Number 1 is nitrogen plus hydrogen gives you ammonia. There are 3 steps to balancing equations. Step 1 is draw a line under the arrow. Chemical equations consist of chemical formulas. Chemical formulas have both reactants and products, so we draw a line in order to separate these. We have reactants on the left side and products on the right side. The arrow usually refers to yield. Step 2. List all elements on both sides. Now that we drew a line separating our reactants from our products, we want to list all of the elements found in both sides. A helpful tip is to keep all elements in order. That way, you can avoid any confusion. Step 3. Add coefficients to balance equations. You may be wondering, how do you know where to add a coefficient? The answer is to start with what element is unbalanced. So let's take a look at what we've done so far. We drew a line to separate reactants from products. We listed the elements on both sides. And now let's add a coefficient of 2 to ammonia. We get N equals 2, followed by H equals 2, the coefficient, times the subscript 3 equals 6. Is this equation balanced? The answer is no, because we have 2 hydrogens on the left side and 6 hydrogens on the right side. Let's add a coefficient of 3 on the reactant side and a coefficient of 2 on the product side. On the reactant side, we get N equals 2, H equals 3 times 2 equals 6. On the product side, we get N equals 2, H equals 2 times 3 equals 6. Is this equation balanced? The answer is yes. The number of atoms for each element is equal for both reactants and products, along with the same total charge, making this balanced. This is also known as the law of conservation of mass. So now it's your turn. Go ahead and pause this video and solve number 2. Don't forget to draw a line under the arrow, list all elements, and add coefficients. You're back. The answer is 2 potassium chlorate gives you 2 potassium chloride plus 3 oxygen. Number 3. Sodium chloride plus fluorine gives you sodium fluoride plus chlorine. We are going to use the 3 steps we previously learned: drawing a line under the arrow, listing all elements, and adding coefficients. I'm going to go ahead and draw the line under the arrow. Next, I'm going to list all of my elements in order. I have 1 sodium, 1 chlorine, and 2 fluorine on the left side. On the right side, I have 1 sodium, 2 chlorine, and 1 fluorine. Therefore, this equation is not balanced. So now what we have to do is add coefficients. I added a coefficient of 2 in front of sodium chloride and a coefficient of 2 in front of sodium fluoride. On the reactant side, I have 2 sodium, 2 chlorine, and 2 fluorine. On the product side, I now have 2 sodium, 2 chlorine, and 2 fluorine, making this equation balanced. That's it for this video. If you enjoyed it, don't forget to subscribe and give it a thumbs up. Thanks for watching.